Hey, welcome back to lesson 11 of SE301. In this block, we're going to be talking about net present value. So net present value follows directly from the last lesson where we were talking about time value of money and life cycle cost analysis, where, hey, your system will have a cost profile associated with it. Each year it's going to cost a certain amount of money. And money that's spent later on is different from money that's spent right now. So what we have to do is we have to convert everything that's spent down the road into a present value so that we can sum it together and determine how much our system is actually costing in today's dollars. So basically we use the term net present value, and net present value is where we take all those future costs and convert it back to present dollars in order to determine how much our system is actually costing. So it's easier to work through an example for net present value and to help discuss it. So here's an example problem. Suppose you're looking at a manufacturer for the Army's MREs and have been asked to consider the purchase of machinery that could be used to manufacture the ever-popular dessert item in the MRE. The Hershey Corporation has said they can provide the following options. The characteristics of each set of machinery are as follows. Both have a service life of 5 years. So they can produce Reese's Pieces, which is initial cost $55,000, annual operating cost $35,000, sorry, $3,500, and salvage cost of $5,500. Or you could have Kit Kats, $53,000, $3,600, $6,300, respectively. And assume we're using a 12% discount rate. So if we're looking at Reese's example, and we actually construct our life cycle cost profile, we can see right here that year 0, we're spending $55,000. So that's cash out. Then year 1, year 2, year 3, year 4, year 5, we're spending $3,500 in operation cost. And then finally, in year 5, we have that salvage cost, so we're getting $5,500 back in. So what you can do from that is you can then convert each of those values into present dollars. So year 0 is a pretty direct, go straight over. Year 1, we had a $3,500 expense. We convert that to present value. That comes out to be $3,125. We do that with year 2, year 3, year 4. Year 5, because we had that salvage cost in there in addition to the operating cost, is $2,000. And so we convert that over to present dollars, and we get $1,134. And now all we have to do is sum those, and we get that the total cycle cost of the Reese's solution is negative $64,496. So what's a useful tool for doing all this is Microsoft Excel. So just working through Excel for a second. So we have our 2 design alternatives. So we have Reese's, we have Kit Kat, and we have year 0, 1, 2, 3, 4, 5. Let's just go back here, copy this chart over. Just so I have the values handy. So Reese's has a initial operating cost of $55,000, Kit Kat negative $53,000. Reese's is $3,500 per year. And Kit Kat's negative $3,600. Then we had that salvage cost at the end, so $5,500, $6,300. All right. So all these values on here are the future expenses. So right now we'd be paying $55,000 up front. And over year one, we're spending 3,500. Year two, 3,500, 3,500, 3,500 for the operation of that machinery. Then we spend another 3,500, but then we'll get $5,500 back when we sell the machinery. All right, so we're assuming a interest rate of 12%, sorry, a discount rate of 12%. And so we have our two different alternatives. Let's convert all of this to present dollars. So this would be 5 by 1 plus, let's lock in the cell. And that would be raised to net value. Meanwhile, this for the KitKat would equal something similar. 1 plus the interest rate. Let's lock in that cell. And so because we're using this equation, we can just copy it across. So you can see year three, for example, this is you taking $3,500, converting it back to present value using the equation we saw on the earlier slide. And so this is giving the value in present dollars that each of these design alternatives is costing per year. So now all we have to do is sum the two. You sum the cost over the life cycle, and that gives you the total life cycle cost in present dollars. So you can see right here that the KitKat option is going to cost us $62,400, and the Rhesus option is going to be cost us $64,500. And so if we want to go for the cheaper option, go for the KitKat option, right? So cost analysis is very important. Again, it's the final step of solution design. And everything kind of goes hand in hand with looking at life cycle cost. You have different costs that occur throughout the system life cycle, and you have to account for all of them. What you end up coming out with from your analysis is a cost profile. Each year, your system is going to cost a certain amount of money. However, because money is not static, it changes value in time. There's a time aspect to it. You have to convert everything back to present dollars. And so you calculate out your net present value. So for each of your design alternatives, you'll be able to determine the net present value. All right. That wraps up today's lesson. Tune in for the asynchronous portion with your instructor, and have a great day.